Alright, so for this question, we're going to start with the equation dx, the integral of dx over x squared times the square root of x squared plus 4. The x squared plus 4 lets us know that we're going to be using trig substitution. So x squared plus 4 is also equivalent to x squared plus 2 squared. The x squared plus integer squared lets us know that this is a tangent, and we know that a equals 2. So for that, we know that our x is equivalent to 2 tangent theta. And since that is that, then our dx is 2 secant squared theta d theta. Alright? So now we're just going to plug this in back into this equation. So we're going to have the integral of the top, so 2 secant squared theta over, and then so we're going to plug this in for x, and the 2 is squared, so 4 tan squared theta, square root, again same thing, so 4 tan squared theta plus 4 d theta. Alright, so this is going to be equivalent to the integral of 2 secant squared theta over 4 tan squared theta. You're going to take out your common factor of 4, so square root 4 times the square root of tangent squared theta plus 1 d theta. Alright, so that's going to be equivalent to the integral. This is 2. 2 times 4 is 8. So 2 over 8. That goes across. So secant squared theta over 8 tan squared theta, square root. This, using your trig identities, is equivalent to secant squared theta. So secant squared theta d theta. Alright, so this simplifies to 1 over 4, so that can come out because it's an integer. So this is equivalent to 1 over 4 integral secant squared theta over tangent squared theta, and the square root of secant squared theta is secant theta. This, you're going to cross 1 out, so you're going to have 1 over 4 integral secant theta over tan squared theta d theta. And now you're just going to split these up, or not split them up, use your identities to convert them. So you're going to have 1 over 4 integral secant is equivalent to 1 over cosine theta, or 1 over cosine theta, and tan squared is equal to cosine, or sine, sine squared theta over cosine squared theta d theta. So you're going to keep change flip to get rid of the fractions. This can come to the top. One of these are going to cross out. This is going to cross out. So you're going to be left with the 1 over 4 integral of cosine theta over sine squared theta. Alright, d theta. So now we're going to do a little bit of substitution. So your u is going to be equal to sine v. So that means your dv, or your v actually. So that means dv would be equal to 1 over cosine theta, or 1 over cosine v d theta. So that means you plug this in, and we're going to have 1 over 4 integral cosine theta over v squared times 1 over cosine theta dv. So these are going to cross out, and you're going to be left with 1 over 4 integral. Now this is going to turn the v to negative 2, because you're going to be left with 1 over v squared. You're going to bring that to the top. You're going to have v to negative 2 dv. Alright, and then you're just going to do the integral, which you're going to get negative 1 over v. So 1/4 times negative 1 over v. You're going to plug this back in, and you're going to be left with 1 over 4 sine v, or theta. It's 1 over 4 sine theta. Or this is negative as well, so negative 1 over 4 sine theta. And then you're just going to plug this back in to your, with your tangent and all that, and your final answer will come to the square root of x squared over 4 plus 1 all over 2x plus c. And that's your final answer.